All right, we're going to get started. So thanks for coming to our first in-person meetup in several months. I'm pretty excited to have Chandler talking about NLP and Microsoft for hosting it. So before we get started, I usually just like to go through our sponsors real quick and do a couple intros and go over a couple upcoming topics. So Verint Technologies is a defense contractor company. They do a lot of software engineering, data science work. They work a lot for federal government contracts. If you're interested in learning more about them, you can reach out to me or go to verintech.com. ClearEdge is another defense contractor company doing a lot of data science, software engineering, big data work. If you'd like to learn more about them, you can reach out directly or talk to me. Arius Ventures is my company. I usually don't talk much about that, but if you're interested in learning what we're doing, just talk to me afterwards. I don't have a slide for this, but I'm very honored that Microsoft was willing to host us, so I wanted to give them a couple seconds. Devin, did you want to introduce yourself?
Yeah, thank you all for coming out tonight. I know a lot of people aren't familiar with Microsoft being local to the Central Maryland area. I've just joined in the last year or so. Jason and I worked a very difficult, hundreds of millions of dollars proposal together a couple years ago, and that's when I first met him. And we fell in love. And ever since then, we're doing all sorts of stuff together. Jason's just has a recent podcast, right? That's getting out there, right? So we're working on that together with AFCEA. If you're not familiar, please look up AFCEA.org. It would be a great time to get engaged. But Jason said, hey, I want to get folks back in person for DataWorks, and reached out and was like, yeah, I think we got a spot that'll work out great. So so glad that you guys can come out. Microsoft is investing a lot in the local area, some new buildings. There's a lot of work in Virginia. There's a lot of work here. I'm going to let Nick just talk briefly. We lead some AI and ML teams here, right here at this facility. But just want to say thank you all for coming out, and I hope have a great time tonight. I do want to mention just the Wi-Fi password is up there, and if you need to go to the restroom or exit the building, please grab either myself, Nate, if you're going to be hanging around, and then Mike, one of us. Make sure that you can get in and out if the doors do lock behind folks. Nate, did you want to mention something about your team since it's DataWorks and you are leading AI?
Yeah, so I'm a manager for the AI platform, so both we're definitely hiring people, and also for people that are interested in the government networks, the AI platform will, if it's not available already, will be available soon. That's what we're working on. Yes, if you have any questions about Microsoft jobs, I can definitely hook you up. There's a wide spectrum of things, and then also if you're interested in just using the platform and having a job, I'm definitely going to look up something different for what's going on with Azure.
Yeah, we're going to be doing, we have a license agreement with OpenAI and GPT-3. So there's stuff out there for you, right?
Yeah.
Cool. Anyway, thank you, Jason.
Yeah.
Appreciate it.
Thank you for the space.
Yeah, if you haven't heard, companies are hiring. I know not a lot of people know that these days, but
any kind of data science capability or interest.
So just a quick announcement. So next month is our first conference. Pretty excited about that. I have another slide about that in a second. And in July, we're going to be doing a presentation on IoT. A professor from UMBC, probably going to be back in person in UMBC, assuming nothing goes wrong with that. We have a newsletter. If you're interested, I post interesting articles, local and general, and some tutorials. Devin mentioned we are doing a podcast now. It's affiliated a little with AFCEA, but it still could be of interest to people in the audience. All sponsors are hiring, always looking for speakers, always looking for people that want to get involved. Just reach out. So we probably only have about 15 seats left on the conference. We got about 100 RSVPs at this point. It's scheduled for 2 weeks. It'll be at UMBC. We do student tickets. They're like $24. Regular is like $74. Little secret, if you do want to register, there's a lot of discount codes, especially if you are part of a meetup, maybe. You might get a discount code. And if the person that running the meetup runs the conference, you might get a discount code. So let me know. We have a lot of cool speakers. We have everyone talking about drones to data governance from the state of Maryland. Chandler's company, Big Bear, is talking about data science and AI. People talking about investigative journalism, NLP with robots. There's a lot of interesting things. Food will be there, and more importantly, alcohol will be there in the evening. So if you'd like to drink with people, please join us. I'm not very good with the Chandler introduction, but and I know he introduced himself to basically everybody individually, so I don't think I have to do too much. But Chandler is a data scientist with 8 years of experience in SIGINT and intelligence community. It's not on the slide deck, but I think more importantly, as you kind of saw as he was doing it, I mean, I think he's kind of a natural for this workshop, right? I think he's a natural for going over this material. I know he has a lot of background doing data science instruction. He recently taken over some ownership or some leadership responsibilities running the innovation lab. Is that correct?
C&E, cyber engineering.
Yeah. I'm sure you're going to talk a little bit about that.
Just a little bit, maybe.
So with that, the last thing would be, obviously I'm not very good at ordering food. There's a ton of Subway. Please eat 3 sandwiches each. There's a lot of beer. Please drink 2 beers each. I will take the Coke Zero, so you don't have to drink that. And then there's chips and everything. If there's anything else, just let me know. Other than that, I'm going to hand over to Chandler. Thanks.
So I did take some time to already introduce myself a little bit as everybody was kind of filtering in and getting situated. So my name is Chandler. If you have to think of Chandler Bain, that's okay. I'm pretty sure that was probably in the wheelhouse of what my mom was going for when she named me. So primarily, my role now, I am the lead data science researcher for the Cyber Engineering Innovations Lab for Big Bear AI. But as I mentioned in our previous conversation as you guys were coming in, this work that I'm going to be showing you today is based off of a hobby of mine. So I started my career as a linguist. I was not a very good linguist. By that I mean I was successful as a linguist. I could perform the duties. I learned the languages. I was an Indonesian linguist by trade, but I picked up Tagalog, Malaysian, and a whole slew of dialects. But what I mean is I wasn't a good one is that I would get bored very easily, right? Once you know the vocabulary, you know how to create the sentence, you know how to hear the words that people are saying and interpret them to other people around you, it becomes very routine. So that just wasn't very good for me. So I wanted to look at different ways that I could leverage my interest in language into what I'm doing now, or things that interest me now, which is obviously data science. So looking at natural language processing, I'm assuming that this is a term that most of you have probably at least heard of before, right? It's something that's all over. Most TED Talks, introduce something to do with data science, anything from NLP to image recognition. If you follow, Microsoft mentioned they have their jobs and things that they post, and they probably have like NLP specialists, right? This is a whole field that you can specialize in, and it all deals with how we handle textual data or audio samples of human speech, right? And how do we allow ourselves to kind of accelerate the interpretation and vectorization of those signals into something that a machine learning algorithm or an AI can then use to provide solutions such as things like named entity recognition, sensitive identity, sensitive information detection. So there's a whole slew of different things that you can use NLP for. So think about anybody here, I know we have one military person in the room, anybody else here military, government worker at some point? All right, so if you remember ORM, right? Sensitive information, there was a huge leak, right? It's kind of a problem, right? So being able to detect where that sensitive information might be being pulled from, right, can lead into mitigation strategies on the defensive side as well. What I'm going to be talking to you about tonight, though, is for sentiment analysis, specifically for marketing. The reason why this, I think, is very interesting, I don't know if anybody here has ever tried to set up a paid advertisement campaign before through Facebook or something like that. I did it as a joke. So you can get very precise in who you target with an advertisement. And I had a buddy of mine that his anniversary was coming up with him and his wife. And so we created this like 30-second video that was really funny, and it was like a whole gag that we put together for him and his wife for their anniversary. And then we just spammed it on Facebook. It only cost us, I think it was like $30 in total to get a whole month of him just continuously getting this ad so they wouldn't forget his anniversary. It was a good time. But when I went back and I was looking at the data, one of the things that I noticed is that you had all these metrics that were available to you that allowed you to assess the performance of your ad. Right? You had things like the number of likes, the number of people who watched it for more than 3 seconds, the number of people who watched it for more than 15 seconds. Right? There were all these different ways to quantify the success of your ad. But what there wasn't a lot of was ways to determine how people were responding in the hundreds, if not thousands, of comments that you might be getting. Right? So you can export those comments from Facebook, absolutely, but there's not really anything that's labeled there to give you any indication of if the comment is positive, negative, if it's good or bad. Right? So there's not really any way for you to identify how people are responding. Even more so with that is, we'll kind of talk a little bit about this later, but differentiating between a positive comment and a sarcastic comment.
Are you talking about the comments that they respond to when they see the ad?
Well, so in Facebook specifically, no, because they don't really comment on the ad itself, but for like Twitter tweets, right, they'll post text along with it.
Right.
You can respond to some advertisements on Facebook, but it's usually not the ones that play on videos. It's usually like it'll have a blocked out space that it posts the advertisement to. So people will comment on that or like it. Typically you see that with people who try to advertise a service or advertise a product. One of the things I always like to point out to people is when they look at video games that are coming out. I'm a gamer, so if you're not a video gamer, that's fine. But if a new game's coming out, you're going to probably start seeing ads for it if it's something that lines up with your profile and Facebook and all the data that they have about you. And then you can go in the comments and you can see how other people are responding. Like, are they excited about the game? Are they talking about how bad the trailer looks, the gameplay looks terrible, right? So you can see all that. So those are the comments I'm talking about specifically.
Can you run
Related to
Jupyter and pip install?
I'm sorry?
Can you run pip installs on Jupyter?
Yes. Yeah. So I do have a notebook. Thank you. I kind of get carried away sometimes and I talk a lot. I do have a notebook for you guys this evening. My notebook's going to be a little bit different because there's a section in there where I like to preface by showing you a success of the efforts that you're going to be doing here tonight. So I'm going to show you a finished model. You're not going to get to see the model. I've got it wrapped up in a PI file because it's mine. Worked very hard on it. It took me a while. But it includes textual preprocessing, things like that I do. I will show you how to do some textual preprocessing tonight. It's going to be very minimal, very basic, but it at least gets you an idea of what you need to do with the textual data that you're working with in order to be able to run it through a model. And then you will get to run a model. You'll also get to export the model so that you can use it for future projects. And as I said previously, if this is something that interests you or something that you want to just try, continue to get better at, it's absolutely a resource that you're able to use. They did post the link to the GitHub page where it's at in the comments section for the meetup. So if you go to the meetup page, you'll be able to get there and just download the notebook. So if you don't have libraries installed on your laptop already, you can run that code cell right there. This is the main ones that I could think of that most people don't have just by default. And the ones that aren't already brought in when you download Anaconda. So if you have another one that you need to download, you can just substitute the name out with TensorFlow and then be able to run that pip install. Right. The .q just makes it to where it doesn't do that whole thing where it says requirement already satisfied, so you don't have to see that a million times if you want to have that in the future. Right. So before I get started, I know I kind of prefaced that very long-windedly. Do I have any questions about what we're doing? Yes?
I apologize in advance. I'm a person, if it's
No
out
worries.
of left field, but you mentioned that you were a linguist and the languages you specialized in. And I'm wondering, as a linguist, if there's mathematical underpinnings to the language, that allow you to, move from one language to another, and if this
Absolutely.
is specific, to one language. So if you were doing this in Chinese, would it be different?
So, to answer that question, absolutely, yes. However, the model that I'm going to introduce to you is only going to be as good as the corpus, which the corpus is the amount of data that you're using to train it on, right? The samples that you're using to train it. So you'll hear a lot of pre-trained models, like the BERT-based model. which the model I'm going to show you as the finished product is a BERT-based model. They have corpuses that include millions and millions of textual samples from all different sources, not only for language-specific purposes, but also for the source that you're getting it from. Think about how humans speak in different, different areas, right? How I type something in a social media post might be different than a technical blog post that I post on my company, right? Or it might be different from an email that I send to my coworkers, right? So there's varying different levels of language analytics that go into deciding what corpus you're going to use, how you're going to structure your model. But language is one of the things that they are currently in the industry trying to solve for human language tools at large. There are some great ones out there, some I can't speak to obviously in this venue, but just from looking at everything that Google does, right? I'm sure Microsoft has some efforts that they've. I want to make sure I give proper.
Thank you.
Yeah.
Appreciate it.
I'm most familiar with Google, but I'm sure Microsoft has some amazing products. So like looking at speech to text, being able to run products and services like Siri, Alexa, all those kinds of things. Language is a huge barrier that has to be addressed, right? So if I build something specific to one language, then it probably won't perform well introduced to a new language because it'll be something completely different, similar to how a person would interact. So we're going to go ahead and get started. Again, you can download the notebook. I'm not going to run any of the pip installs because I already have them, but you can run it if you need it. So these are the libraries that we're going to import. So some of these, actually scroll a little too far. Some of these are pretty standard. So you have pandas, NumPy. Anytime you're working with data frames or arrays, that you're going to see people importing pandas and NumPy. The RE up there is for regex. I do use a little bit of regex in this notebook. I'll point it out to you when we get there. If you're not familiar with regex, it's just regular expression. It's pattern matching language. I learned regex when I first learned Python because I use them to script through things. They're very co-compatible with doing certain types of processes. So if you're trying to pull out text and you want to get only specific things, regex is a way to really minimize the amount of typing you have to do to tell it what you want to find, right? So there's other libraries in here. NLTK, that's Natural Language Toolkit from Python. It's very useful. It's got, it is a little bit older. It's kind of like the old school on the block kind of library for NLP. I do still find it valuable. I still do find it useful. You'll hear other people reference libraries like Spacey as kind of like the next NLTK. Or you might see like PyTorch and TensorFlow. We do use TensorFlow in this notebook. I don't use any PyTorch or anything like that, but those are some of the big libraries that you'll hear associated with natural language processing. And then the Seaborn and Matplotlib are obviously just going to be for visualization purposes. I do kind of, I'm kind of partial to this, so I have word cloud in here as well. So word cloud as a library, it's really great for making quick little word clouds, the images of a word cloud, but it also does come with its own stop word list for the purposes of filtering things out of the word cloud. I like to include it in my notebook because what I do is I combine it with the NLTK stop word list. So I merge those two together, just kind of out of force of habit, something I learned.
So are you using that for like frequency counts?
Not necessarily frequency counts. I'm filtering out words in my textual samples if they're present in the stop words list.
Oh, okay.
So words like they, them,
Okay.
it's, right? I don't care about those words, so I'm just going to drop them out. And then the TensorFlow stuff I'll get to a little bit later. The TensorFlow datasets is going to be one of the days where we're going to pull the dataset for our training purposes here. It's the IMDb reviews dataset, very common. There's a lot of courses on like Coursera, Udemy, those kind of platforms that use the same dataset. If you're interested at all, I can point you to some really good ones that I've found just in case you want to do. They're self-paced. They're great resources. And then the filtering warnings, I just don't like those things. So it's a red banner that pops up in your notebook. I just tell them to go away. And then the last one is my model. So again, it's wrapped up in a PY file. So in order to demonstrate, because the purpose of this is not just sentiment analysis at large, we're specifically talking about sentiment analysis for marketing, right? So how would you, let's say you're interested in running an ad campaign, or you're interested in seeing how well a marketing campaign is doing, how would you quantify the success of that campaign over a period of 30 days versus a period of 3 months to a year? What would be some things that you look for? Yes.
Look at some metrics like click-through rates.
Click-on rates?
or,
Okay.
Just, yeah.
Yep, so the number of clicks, right? How many clicks are people from, whatever my target audience is, clicking on my ad, right? How many people are opening it up?
How many purchases are they? I mean,
Okay.
that's like the end goal.
Yeah, resulting purchases, right? Because usually if we have an ad campaign, we're trying to get people to either buy a product or subscribe to a service. RSVP, right? So how many people, in short term, right, you might say, how many people go to our website, right? Maybe we include like a link to our website in the ad. How many people click on that link to go to our website and we get more web page views, right? That might be something. RSVPs is a great one. Anything else?
How many people talk about it shortly after seeing the ad?
How many people talk about it? That's a great one, right? So you might run an ad, and let's say you run an ad for, anybody have like something that they're coming out soon that they're super excited about? Game, movie, anything?
Python class.
Python class? This one? Yeah. Yeah. So maybe we launch an ad. Jason puts together a nice ad for us with my nice pretty picture that you guys all got to see. That was from 3 years ago, by the way, so I looked a lot better. I've since gotten a lot more comfortable in the AC. But let's say we put out that ad, right? We're looking at how many people are talking about that ad, right? That's actually going to line up very well with what we're going to show you today. The ad that we're looking at is from 2018. So it was when Nike went through and announced their 30th anniversary of Just Do It, for their Just Do It ad campaign. They picked Colin Kaepernick, previous quarterback at the time, to be the face of their new campaign, right? Obviously, we're not going to get political or anything like that in this class. What we're looking at here, though, is the polarized effect that selection had on how people were responding to the ads, right? Because normally when Nike would come out with their Just Do It campaigns, usually it was like largely successful, right? You would get a lot of people talking about the shoes. They usually would launch a whole new line associated with the ad campaign itself, right? So you'd get a lot of positive responses from that ad campaign, right? However, when they selected Colin Kaepernick, it created some very, kind of controversial, responses from people in certain groups, right? So that's a great place for us to study as data scientists, because now we have these polarizing opinions, right? And one of the things that you'll hear is sentiment analysis is often referred to as opinion mining. So we have these polarized opinions that we can now go through and train models on, so that the next time somebody launches an ad, we have a model, right, that is built on those polarized opinions. It's been trained for those polarized opinions, and we'll be able to accurately assign sentiment to those new ads, right? So we'll be able to quickly digest how people are responding to our ads by how they're talking about it, right? So in this case, it's going to be Twitter. They're going to be retweeting or just tweeting about it. The data set itself has over 5,000 tweets. It is very much so limited to a 16-hour window, because there's obviously a lot of tweets that happen. But it's tweets that mention Just Do It or other terms, key terms that are associated with Colin Kaepernick and the ad campaign itself. Okay. So that's kind of framing what we're going to do. This is where my notebook differs from yours. So you'll see our data. So this will all load up for you the same way. If you're interested in researching more about the data set, you can go to Kaggle. It's hosted on Kaggle. If you're not familiar with Kaggle, it's an open source data science competition platform that's sponsored by Google. So there's all kinds of different stuff you can get involved in if you want to practice and all that kind of stuff, right? So in here, I try to make sure all of my code is always commented out very well, so that if anybody was to read it, they'd be able to understand what I was doing and reasons why I was doing it and how I was proceeding. I did spend some time building instructional material, so I actually developed data science courses, and so I try to reflect that in how I actually code myself. But what we're doing here is we're just going to read a CSV. That's the format that the file's in on Kaggle. So I've just downloaded it. That CSV is located. If you need me to zoom in, I can try to zoom in for anybody in the back. You guys are good. Sorry, I probably should have asked that before getting this far. But so if you go to Kaggle, you'll download the CSV, and it just has all the tweets. Now, the file itself has a lot of different fields available, or features, or columns, however you want to refer to them. I'm specifically just going to pull out 4 that I think are easy to digest and actually look at. So we've got the tweet created at, that's going to be our timestamp, the full text, the user's screen name, and the user location. We're not going to do anything with the screen name, we're not going to do anything with the user location in this example, but these are just so that we can have some frame of reference for who the people are, where they're located, as they're talking about our ad campaign. Right? So I've already outputted the data frame. I did do some quick imputation for any of our missing values. I just put unknown because there was a few missing values in the location and screen name. Not anything I wanted to stress about or make a big deal about with an imputation strategy. So I just filled them in with unknown. And then I went through, I converted the tweet created at to a datetime object because it was just a string object. I'm actually going to use that in visualization, so I just wanted to go ahead and have that ability to extract out the pieces that I needed. And so I output the data frame. You can see we've got the timestamp, the full text, the screen name, and the user location. Right? So from a marketing standpoint, right, you would get the metrics associated with how many people are tweeting and how many people are talking. I can give you all of those aggregate information pieces, right? Most of the time, if you're the person running an ad campaign, you already have all of those aggregate features available to you. You have the ability to see the number of tweets, the number of likes, the number of posts, right? All that kind of stuff. So that's nothing new. But what I'm going to focus on is the tweet full text. Right? So as I said, we're going to skip to the end. So this is actually going to be a model that I've developed. It's a BERT-based bidirectional LSTM model. So I took the BERT model, which was really good for sequencing. For training problems, NLP problems for sequencing. You'll hear various different versions of the BERT model. You'll see like Roberta, the mini BERT, all those kind of things out there. It's not the only type of pre-trained model that you can use and not the only type of architecture you have available, but it is one of the most widely known. There are many out there. I encourage you to look for them, do some research, or if you want to talk to me afterwards, I'll be happy to share some information. But I took that model, that pre-trained model, and then built a model architecture on top of it, and then trained some additional data sources that I have that are things that I've either purchased or have ran through it organically and have those data sources available. So what I'm going to do is I'm going to run my CP sentiment function that's in my wrapper. It includes all of my textual preprocessing. I did kind of mitigate some of this. So in Twitter and Facebook and social media at large, what's the #1 way that you think people communicate without using text?
Without using text?
Emojis.
Oh, emojis?
Right? Yeah, without using text, they like to use emojis, right? So not obviously something that we're doing here, but one of the things that I had to do separate to my traditional methods was I actually had to be able to characterize the emoji itself, right? Create a vector count for it, and then be able to apply sentiment to the emoji itself, which included a lot of nuance because certain emojis mean things that...
Sounds hard.
It was not hard, just a long time. I think most data science problems are more about the time and effort, not necessarily the complexity. There's a lot of really good resources out there, so I don't want to dissuade anybody. So I know if I say something, it might sound like, oh, that sounds like it's going to be difficult, or it's time consuming, absolutely, but definitely possible. But for this one, I didn't include any of that. So what I'm doing is I'm passing in the tweet full text, and I just wanted to apply a sentiment label, positive or negative. This one I didn't care about neutral. I just wanted to give me polarized opinions, positive or negative. And then I wanted it to give me a score. And the score essentially allows me to see how positive my algorithm thinks it is. Not necessarily how positive the message itself is, but how positive my algorithm thinks it is. Right? So it's a very minute difference in terms of how you might think about it, but it is something that's specifically important to identify. Okay? So you can see that we have 2,500 about, right? 2,500 positive and about 2,500 negative responses, right? Now, I've previously I said you might want to track these things over a period of time, right? Because really, if I have a marketing campaign, it's not going to be a one-off, right? I don't just put my ad out there and then I say, okay, well, how did people immediately respond in that hour that I put out my ad, right? I might want to look at the length of time that my ad is running and see if there's fluctuations. There might be some patterns and underlying seasonality or trends that I might be able to capitalize on, or compare how my ad performs in different markets, right? So here what I've done is, because this is such a tight window, I extracted out the hour for when this ad was running in this specific sample of the data set that we have. So I extracted out that hour, and that's what this cell is down here. And all I did was group the sentiment by that hour, right? Aggregate the count of it so that I could track the fluctuations over the duration of the ad campaign. And sorry, this visualization is a little bit bigger than what I had hoped. When I was doing this on my own computer, it looked like it was going to fit perfectly now. But anyway, so you can see here that I've got positive and negative sentiment, right? And I can check the fluctuations over time for the duration of the campaign. Now this is 16 hours, so the insights to derive from that probably are not very meaningful, right? But if I wanted to look at the immediate responses before the ad was announced featuring Colin Kaepernick, right? How people were sentiment responding to Nike in general, right? Or Just Do It, or maybe Nike products, right? I could look at the sentiment surrounding the time before the ad was announced, and then look at the time surrounding after the announcement, and I can compare the trends in how that fluctuation might change and how people are responding, right? So there might be a lot more positive than negative beforehand. It might even out afterwards, right? It would be something that we would need to analyze, right? But it could provide some useful insights. To give you a use case that's not related to the Nike ad campaign at all, in Facebook, if you're setting up targeted ad campaigns, you can get very specific in who you're marketing to, right? Right? You can get down to like, I want to target, men 18 to 25 who work in this industry, who live in this area, right? You can target women 35 to 40 who, have kids and all that kind of stuff, right? You can get very specific. So if I have a product or I have a service that I'm trying to sell, I'm trying to get those likes, I'm trying to get the people to purchase my product, subscribe to my service, I might want to know where I'm getting the most bang for my buck. Right? I'm a small business, I don't have tens of thousands of dollars to throw at a marketing campaign. Right? Every dime that I spend on ads is coming out of my pocket, it's coming out of my bottom line. So if I can look and compare, right? I set up a 30-day campaign in different markets, right? Different groups that I'm targeting, I can compare that sentiment fluctuation over time and see where I'm getting the most bang for my buck. Right?
You only do that on Facebook?
Not just Facebook. You can do it with Instagram, you can do it with Facebook. With Instagram, you might have to scrape the comments because I think Facebook is the only one that actually exports them. I don't know about LinkedIn. I haven't ran an ad campaign on LinkedIn. To be honest, the only ad campaign I've set up is on Facebook. But YouTube, I know you can scrape the comments off of YouTube by writing a Python scraper, and I know you can do it off of Instagram. So it might require you to do a little bit more finesse in where you're gathering your data, but it's absolutely something that's good.
But you're talking about that specific details, like demographic information, like women, 35, kids.
Well, you're comparing the sentiment
Oh.
of how people are responding in those demographics. So you would set up an ad campaign, and it would be like for this specific group.
Okay.
And then you would get the sentiment for that, and then you would set it up for another group.
But only so Instagram also allows you to focus your ads.
I'm fairly certain because it's built on the same framework as Facebook for their ads.
Okay. Because I'm familiar with Facebook. Facebook has that, but
Yeah, I would assume so. Again, I have not ran one, but it's built on the same framework as Facebook, so I would assume that it has the same capabilities.
that would be great. If Twitter had that, that'd be awesome.
Yeah, Twitter is a little bit more nuanced. You have to get information about the user. For Twitter, one of the biggest use cases I've seen is looking at location data. So how people are responding in specific locations. It's kind of more of a macro analytic type. but you're looking at how you're performing in certain areas, which really only matters if you care about an international or national market, or have something that has that far reaching. Right? So there's variances depending on what you're trying to accomplish and what kind of data that you're going to have access to.
So with Facebook, would you have, oh, that's right, you're already paying for the ad, so you.
Correct.
Okay.
So this is just over that time frame, looking at it. So that's kind of that's the quick and easy, like this is the goal that we're trying to get to. So now we're going to start from the top, right? How do I get from point A, which is having data, to getting something like that, right? How do I produce a model that can apply sentiment? Okay. Well, the first thing is if you notice in our Twitter data, there were no labels, right? We had to create the labels. It didn't come with labels that told us positive or negative. We had to create those. So how do you think that we are going to be able to create that? What do we need?
Could you repeat the question?
What do we need to be able to create those labels? What's that?
You need to train your model.
You need to train a model. Okay, so how do you train a model to be able to identify sentiment? What do you need? What does the data have to have?
Descriptive words.
Well, it has to have something that tells you if it was positive or negative, right? So most people, when they look at pre-trained models or they look at a way to get a data set that has labels, they'll use openly available resources, right? Like the BERT-based model, it's openly available. You can pull it in from PyTorch or TensorFlow. You can train on top of it. Data sets like the IMDb data set that we're going to look at have labels. One of the kind of short ways that you might also find other review data sources, think about your Google Play Store or your Apple Play Store, right? People leave reviews on apps, right? Okay, so that is a data source that you can leverage. But how do you tell if it's positive or negative in that data source? Number of stars, right? So I only bring it up to kind of get you thinking about other alternatives that might not be just the traditional, like, oh, let's look at IMDb or a pre-trained model, right? You can get creative in how you're finding data sources to leverage to be able to, have those labels available. If somebody gives it a 4 stars on, Google Play Store, their review is probably going to be positive. If they give it 1 star, it's probably going to be negative, right? So you can kind of leverage that. It might not be as in tune with the target of your model, right? So Twitter is different than Google Play Store in terms of how people are typing out their responses, right? But it might get you close, right? It might give you some samples to work off of. So we're going to use the IMDb data set. As I said, you can pull this directly from TensorFlow. It's in the TensorFlow data sets. So I'm just going to pull it in. That as supervised equals true is just telling it that I want the labels, right? I don't want to have to worry about trying to use this as like a validation set or anything like that, or new data. I want the labels so that I can train my model, right? So it's going to give me that positive or negative sentiment. Once you pull in the data, we're going to start entering it into our textual preprocessing steps. Okay? What do you guys think I mean by textual preprocessing? Just in general, what comes to mind when I say textual preprocessing?
Clean out like all the little like marks or commas or something like that.
Punctuation.
Yeah, any kind of information, stuff that's not needed.
Yeah, punctuation is not needed. It's eating up space in my vector. I don't need it, right? I don't need all the periods, all the exclamation points, all that kind of stuff. I'm just going to get rid of that. Okay. What else? I think you raised your answer. What's that?
Capitalization.
Capitalization, absolutely, right? Do we all type in lowercase letters all the time?
No.
No, right? But it can be very different to a computer, to a machine, the difference between a capital C and a lowercase c, right? Those mean different things. Those can be there, even if you look back to the ASCII table, they line up differently, right? So we want to be able to make sure all of our textual samples look the same. Okay. In terms of lowercase, right, that's pretty much the default. Everybody just sets everything to lowercase. But we want it to look the same. What else might we need to change to make it all look the same?
I was wondering if actually the capitalization could convey some kind of sentiment when people just call capitalized words that might say something.
Yep, so it can. Those usually require a human verification to be able to say, like, this isn't just somebody, like, not to knock on my grandma. My grandma doesn't know how to turn off caps lock. It's been on since 1997, she can't figure it out, I've given up. But yeah, you can have human verification that goes through and says like this, the capitalization here is proving, that they might be more aggressive, or they might be more, emotionally responding. That gets more into like tonal analysis as opposed to sentiment, because sentiment usually is on a scale of positive, negative, and neutral, right? Very broad sense. Within that, you might get even more specific, and you might say, if it's negative, are they angry? Are they sad? You start, and that's where like the emotion AI piece of it comes in, because now you start trying to figure out how people are feeling when they're typing things out. But absolutely. So what else might we need to do to text samples to make sure that they look the same? We got the capitalization down.
You just stem them.
Stem them. What do you mean by stemming?
So making sure that every word is in the same tense.
Same tense, right? So is bark, barking, barked all need to be treated as all three different words, right? Or can we just say, no, that's one word, it conveys one idea, so let's stem that and just get that root word, right? Now, I will throw it out there as another thing. So stemming is one technique. There's another technique called lemmatization. So you'll hear those two things often in talking about competition with each other, because one way is more cost consumption heavy. So lemmatization takes more processing. Stemming can be a little bit quicker. Lemmatization results in a actual word. Stemming might not always result in a true word, right? So it might misinterpret, give you like, instead of crying, you might get CRI instead of CRY, right? So there's variances on how effective one is over the other, and it really depends on how you're using it, right? And you can always go in and correct those, so it's good to practice both. Both of those techniques are available from NLTK. So even if you just stay with the old school library, you can do that. TensorFlow has stemming capabilities as well as other libraries. Make things a lot easier on yourself. Use those pre-trained, not pre-trained, but pre-built libraries and functions.
Can you just comment on, like, you mentioned that one is more faster and kind of cost-effective to do. Can you, like, is like twice as much, 10 times as much? Like,
I can't give you a specific difference. I will say that in terms of if you wanted to evaluate the performance, you would just have the same function running against the same data set, have one run lemmatization, have one run stemming, and then just look at the process, the amount of time it takes for the process to finish. And you could break that out in a per step basis, and that would give you a general idea how it's performing on your system. Because you can also have variances between what you're doing on your laptops here versus what you have on your desktop, right? Like if I ran this on my desktop, it might not even notice the difference, right? It might not be something I can perceive, but running it on like a 10-year-old laptop, it would perceive it very quickly. Right? So that's also a difference. All right, so the last thing here that I'm going to throw out is padding. Has anybody heard padding before? Okay, so in textual samples and textual analysis, your reviews might be different sizes, right? In terms of length, right? If I feel very strongly about, let's say, a movie review, because that's what we're looking at, anybody here watch, what's a good movie that just came out? Anybody here watch No Way Home, Spider-Man? Fantastic movie, right? All around. That's like the epitome of cinema. That's what cinema was created for. Okay? Tobey Maguire back as Spider-Man. That's what we were here for. Okay? Yeah, spoiler. Spoiler alert. It's been out for a while. So I don't feel any remorse. But when we're looking at that movie, right, my review of that movie, I might have been so emotionally overcome with joy, having seen that, my childhood superhero on the big screen again. So I probably wrote like a 5-paragraph review of the movie, right? It was fantastic. Andrew Garfield was great. The other guy, new guy, what's his name? I don't know. He's okay, but he was okay, right? Might write a pretty lengthy review. Somebody else who probably, wasn't around for Tobey Maguire or Andrew Garfield, they probably grew up on Tom Holland's Spider-Man. Their review, everybody, it was okay. I mean, people were overhyped, right? There was this one weird guy, this short guy, yelling in the back. He cried when Tobey Maguire came on screen. It was a little weird. But his response is probably going to be a little bit shorter, right? But if we want to be able to use those vectors in our analysis, we probably need to standardize the size that we're willing to accept. in terms of what our model is going to see, right? We want to give all equal length vectors to our machine learning algorithm. So what we need to do is pad, right? So the first thing that we're going to do is we're going to set them all to the same length. We're going to set max length. But because that max length might not be the length of all the reviews, or the minimum length of all the reviews, you might get somebody who comes in and gives like a 3-word response, right? We got to be able to get from 3 words all the way out to our pad length, right? Our maximum length of the vector. So we're going to pad it. We're going to add in vectors, sequences to fill in that gap, right? So that's another thing that we're going to see here tonight. So what you're looking at is us pulling in the train and test values. So I'm just going to go ahead and run this. Oh, and I have a name error because I didn't bother to run the first one. Another reason why I'm a super big fan of running things in Jupyter Notebook, because go back very easily. So didn't run this, but obviously this just gives you the information about the data set in case you wanted to source it, like if you use this for any product that you build or a paper that you write or anything like that. Gives you documentation information about the data set. I like to highlight this guy here, Andrew Ohm. If you take any courses on Coursera, he's got videos on YouTube. He does speeches all over the place. I mean, this guy he is a genius. He's a savant. Learn from him. He's a master, right? Check his stuff out. He's very good. But now that we've ran that, this will run. Right. So this just pulls out the train and test samples. And what I've done is I've created empty lists, and I've got testing and training lists for both the sentences, which is going to be the text, and then also the labels, because remember I said I wanted it as supervised, so I have those labels. The next piece down is you're going to see me looping through to append the sentence, the text itself to the empty sentence list, and then the label to the empty labels list. All right, so I'm just doing those in one fell swoop for training and then also for test.
When it comes to padding or picking a length, is there a common, is there a method for picking how long you want? Like, do you go with the median length, or do you just say 100 words and?
It really comes down to where you're looking as your target area. So for Twitter, right? Twitter has a max character length. You could use that max character length, right? For things like open forums, or if you're trying to do textual analysis on, white papers, right? You want to see how people are writing their white papers. You're probably going to have a much longer maximum length. So it really depends on the target of the textual data that you're going to be working with, that you're aiming for. It is important that you train your model on that max length, right? And so if you're going to look at Twitter, I don't know off the top of my head what the max character length is, but let's say 160. What's that?
250.
250? Yeah. Okay, so 250. So I would want to make sure that all of my models were trained on 250 as that max length, right? And then anything that's shorter than that, you just pad up, right? So that way I'm capturing the majority of what I want to look at. Okay. And keep in mind that in terms of max length, once we do our textual preprocessing, like we're removing punctuation, dropping off our stop words, that's actually going to shorten the vectors that you're looking at as well, right? So you're going to have several things that are working in your benefit to be able to capture as much of the textual data as you can. All right. So what I like to do, usually when I teach people, anything to do with data science, it's nice to go step by step and see what the output looks like, right? Because most people could agree that if you get all the way to the end and you don't know what's happened at one step or another, it's hard to work backwards and figure out where you went wrong. So this is just me outputting the first value in our training sentence list. So this is a movie review in our training data. You could change this to the testing sentences and you'd get the first value for testing sentences. I went ahead and added the corresponding label. This movie was a movie starring Christopher Walken, and I really like that they talk about how it's ruining his good name. So that last line there, you can see ruining actors like Christopher Walken's good name. So that's always good to see. I actually don't know what this movie is. I think it's, I don't know. I don't know what this movie is, but it's fine. So you can see that the training label, right? 0, negative, 1 would be positive. And then you could read that text, and as a person, right, you could see how that's negative. Right? They're not thrilled about the movie. They think that there was some cheap things that were done in the movie. Even though they had a good actor, good lineup of people starring in the movie, the movie wasn't good, right? As a person, you can see that, right? So this is going back to our previous conversation, and I don't want you to think of AI as the solution that eliminates you from the problem. I want you to think of it as AI as the solution that augments your capabilities. So you can read that, you can tell me if it's positive or negative. All this is doing is it's going to accelerate.
So is this label assigned by the IMDb database that you're pulling from?
Yeah, it's in the data set.
Okay, so is it like anything less than, I don't know, 3 out of 5 is labeled 0 or something like that?
So I don't think it was based off of stars. I think that they actually had people go through, as part of like a research project, there's a whole paper that was written, and they had people go through and assign the labels for this data set manually. I would have to go back and look, because this data set contains, I think it's over like 50,000 movie reviews.
I never actually, yeah, because I knew the data set exists, I never knew how it got labeled.
Yeah, there was like a whole research project that was centered around this at its inception to be used for like training capabilities and all that kind of stuff. And I want to say the original process was to go through manual. Yeah.
So would this be a way to use, I guess, weight to all the words in that sentence, in that observation, to say, well, you know, for some words like terrible, would definitely be a certain way compared to words like great.
Yep. So, and that's what the actual like building a machine learning model for sentiment analysis is going to do, is it's going to assign those weights, right? So you'll see as we continue on, like we're actually going to tell it the number of words in its dictionary, right? We tell it how many words we want it to know. And then it's going to look at those words, it's going to look at the sequence of those words, because the architecture that I use is bidirectional LSTM. It's going to look at how those words are put in order, and then from there it's going to be able to train itself to identify the weights of certain words in certain sequences. So that's the power of AI here, is being able to generate those weights. Yeah.
Is it a concern, like, let's say you're trying to do something with a Twitter data set and you're training on this, and you needed to shorten the length of each of your training samples? Is that a concern that, like, maybe the sentiment would be quite captured in, like, the longer messages?
Absolutely, right? Think about how humans type and the way our brains work. We might start out feeling one way as we're typing the message, and then we remember something in the movie, and then we're like, yeah, but this was really good, and I really like how they did this, but all of that piece is lost because now we've chopped it off, right? So there's always going to exist a concern that by shortening the max length of the vectors that you're willing to support, you're going to be losing something. So it's always important to inspect. Obviously, I don't expect you to go through and read 25,000 movie reviews. But what I like to do is I like to take a random sample and just inspect what it looks like. And then that kind of helps me frame what I want to do in terms of what I want to set my max length at, what I want to set my vocabulary limit at, right? All of those kind of things are going to be very nuanced in terms of how your text samples look. And it's really a project by project basis. So from there, the next thing to do is to get rid of some of the things that we don't need. So this first cell is just going to combine the stop words list from word cloud as well as NLTK. They do have, NLTK does have other resources available for other languages, so I know that was a previous question. So they have resources available for different languages, including Indonesian, Chinese, things like that. So you can absolutely leverage those capabilities. Here we're just going to use the English ones, obviously. And then the word cloud stop list we're going to add in. You could do a side-by-side comparison of what's in each of these. You can also make your own stop word list, right? You can also append to these stop words lists in your own notebook, right? So if there's a word that you're seeing in your text samples that you're working with, and you're like, I don't care about that word, add it to your stop word list, and then the algorithm will ignore it, right? You won't see it anymore. You're going to remove it from all the samples, right? So you can absolutely get more manual with that if you want to. All right. So I just output what our finished list looks like. So it's words like she's, there, will, only, some, on, right? So obviously words that are what I call like filler words, right? They don't really convey anything in the terms of identifying the sentiment or how the person's feeling. They're noise. Now the next cell here is going to be how we remove those stop words. This isn't the only way to do this, right? There's many different ways to skin a cat. Different programmers are going to do things different ways. For me, this is just the easiest way to break out step by step. So when I'm teaching somebody how to do something, you can see on each line within this for loop what's happening. Right? So the first thing that I'm going to do is I'm actually going to loop over the length of the training sentences based on the index. Right? So I'm going to go through each row, so each textual sample. From there, I'm going to tokenize that sentence. I'm going to word tokenize it. What that does is it creates a list. Right? So it's creating a different Python data structure. It creates a list of the words in that sentence. So it goes from being a string to a list of words. Right? They'll be comma separated. You can output it there and you'd see the list of words. Right? From that, I'm going to then have a filtered sentence where I go for the word in that list of words. Right? So I've got another for loop embedded there. I'm going to go through each word in that tokenized list of words. And if it's in the stop words list, I'm going to ignore it. I don't want it. Right? So my filtered sentence is going to be all of the words that are not in that stop word list. Right? Now, the next things here is that I'm going to convert. So you'll see S equals string, and then in parentheses the filtered sentence. Remember that filtered sentence, its data structure is a list. Right? It's a list of words. I don't want it to be a list of words. I want it to be a string. Right? Because that's when I get to my actual tokenization for sequencing, I need it to be a string. Right? So I'm going to convert it to a string. With that, I've got to remove things like the commas that got added, because when you have a list of things, they're comma separated. So I'm going to drop those out. So the next line is going to be me using regex, and you can see that I'm going to drop out punctuation, anything that's not a word or a white space character. The next line, because when you drop something out, you can't create double spaces. So I'm just going to look for anywhere where there might be double spaces, right? 2 space bars. And if there's double spaces, I just want you to replace that with a single white space. I don't need 2, I just need 1. And then I'm going to assign that S, that variable S, as the new sequence, right? The new string of text for that training sample, right? Now, anything that you do in terms of textual preprocessing when you're training your model, you have to do for the new samples coming in. It's considered best practice. You don't technically have to do it, but it's considered best practice, right? So what we're going to do is we're going to go through the training real quick. This only takes a moment for it to loop through and do this. Again, this is not the only way to do it. There are faster ways, right? But this, I think, makes it very easy to follow line by line. And then once that's done, we'll actually do the same thing. You'll notice that the exact same code is used on our testing sequences. We don't have to do anything with the labels because all of the labels are already zeros or ones. But we need to do all the same pre-processing to our testing sentences that we've done to our training sentences. All right, so that ran. And then I'm actually going to go ahead and run this cell first so that we can see the output, and I can talk about it while this one's running. So this is taking that same training sentence where we saw where they were talking about Christopher Walken and how bad his movie was, right? Even it's ruining his good name. But this is what it looks like after we've removed the punctuation, after we've removed the stop words, after we've gone through and done those very minimal pre-processing steps. These are the words that remain. So you can see absolutely terrible movie, right? You can see things like great actors, must simply worst role history. Right? So as you're reading this, you're like, well, that's not how humans speak, right? But what this is going to enable us to do is to create sequences, right? In terms of characters, numerical representations, and vectors off of this textual sample that our machine learning algorithm is going to be able to interpret, because our algorithm is not going to be very good if we hand it a bunch of strings, right? It's not going to be able to work as well. So what we need to do is we need to hand it sequences of numbers so that it can learn and make that interpretation. So looks like that finished running. So I'll go down. And here is the next step, which is to do the sequences, and then it's going to pad them. Right? So the first thing is the tokenizer. You can see here that I did include filters for punctuation. This isn't necessary because we've already filtered out punctuation. I do it as like a just in case, right? Programmatically, sometimes things happen, right? Something gets slipped through the cracks. So I think it's best practice to always just have multiple layers of filtering out whatever is not going to be useful to your model. But the number of words there, that is the size of the vocabulary that I want my model to have, right? So I'm telling it, you're going to learn up to this many words, right? It's going to learn those words based off of the samples that I provided in training, right? So it's going to build its own dictionary, its own vocabulary based off of the words in the training sample. From there, I'm going to fit it on the training sentence for it to learn, and then I'm going to convert it to sequences using the text-to-sequence method that's part of that function from that library for TensorFlow's tokenizer. Right? So that's a pre-built method. It's not something I created. It's something that's available in TensorFlow. Right? And you can go to the TensorFlow documentation for these methods and functions, and it lays it out exactly what parameters you need to use and how you need to use them. Okay? So once it's done that, it's going to then do the sequences, and then you'll notice that I'm sequencing and padding the testing samples, but I'm not refitting, I'm not reinstantiating my tokenizer. I'm just using the tokenizer that's already been fit on the training samples and the sequences that are rendered from that. I'm just converting the testing samples based off of that text-to-sequence method and then padding. Okay? So I'm not refitting anything. So that takes just a second to run. And then the last thing I'm going to do is I'm going to take all of those labels and I'm going to convert them to a NumPy array, right, instead of a list. That's because from an input perspective for a model, arrays work 10 times better. That's not actually a quantifiable like 10 times better thing. It just needs an array input. Right. So I just convert that. This next portion, I know we're kind of going long on time. Jason, are we good?
Yeah.
Okay. Sorry, I don't want to keep you guys here much later than what you need to be. I hope everybody's been having fun and learning a lot. But for this part, we're just going to build a model. This is a sequential model, so if you're working with Keras, if you've worked with Keras in the past, you've probably heard functional and sequential talked about in terms of model types that you can work with. Sequential deals with having a singular input, singular output. By singular input, I mean you're not having multiple inputs from different sources that are feeding into the same model. You can have multiple input variables, right, that are aggregated into X to predict Y. Okay? In this case, our input is just going to be those training sentences, those text vectors, right, that we've created, and our outputs are going to be positive or negative, right, a binary label. So the first layer that you're going to see in the sequential model is actually going to be an embedding layer, right? There's 3 parameters total. We're only going to set the size of the vocabulary and the output dimension length because we've already done the padded sequencing, right? The third parameter in the embedding layer is for padding, right? We've already done that. I like to do it beforehand in my textual preprocessing step so we don't have to repeat ourselves here. And you'll notice that the dimension includes the same value for my number of vocabulary, right? So that should match. You want to match your vocabulary size in your embedding dimension into the vocabulary size that you use for your tokenizer. Okay. From there, I use a bidirectional LSTM layer. Now, obviously, you guys didn't come here to get the math speak of what all these layers do. Essentially, with a bidirectional LSTM layer, think of long short-term memory. That's what LSTM stands for. So what you're doing is you're telling it to, I want you to elongate how much you remember about the sequences of words. And since it's bidirectional, that means from past to future and future to past. You have just a single direction LSTM layer, right? So you can use just regular LSTM. Bidirectional just means that it's going to look at the sequencing from one end to the other, and then also consider the sequencing from the other direction, right? I have found in my own personal use that I prefer bidirectional LSTM, but it is depending on what kind of project you're working on in terms of what you're trying to do with your data. And if after this you want resources or questions or anything like that, I can point you to some great documentation for all of this as well.
Is the BERT model embedded in that? Or is
No, this does not include the BERT model.
Okay,
this is just our organic model.
Gotcha. Yeah, because I wanted to ask because I knew it's not an LSTM model.
Correct. Yeah. So the model that I showed you previously was a model that I created where I took the BERT model, I froze or made the layers in that model not trainable, and then I built another model architecture on top of it that was bidirectional LSTM. It included more layers than what's here, but built that on top of it, and then used that as kind of like my own working model.
That's kind of the backbone for its.
Right.
Yeah,
I get all the benefits of it
yeah.
without having to go through and retrain it every time I introduce new data to it. And then the last two layers there, those are dense layers. So dense layers are just fully connected layers. The last layer is the important one because that's where we're setting our output dimension. One means it's going to be binary, right? It's going to be a yes or no, positive, negative, right? There's only going to be one type of response, right? In terms of this model, it won't be a 0 or a 1, but you will only get the one number, and that's going to be on a scale of 0 to 1, how positive it is, right? So the lower the number in your output, the less positive the review. So this is just creating the architecture of the model. Outputting the summary shows you the output shapes, so you can track from layer to layer. You want to make sure that they're lining up. A lot of times what you'll see is people get errors when they're creating their model because the input layer of one layer, or the input size of one layer, doesn't match the output of another layer, so it'll create an error. So you want to make sure that you're checking the size, dimensionality of what you're passing through your data. Right? If you try to run something through, it'll give you an error that says like, you expected this shape, you got this shape, right? And you have to troubleshoot. Then we're going to go through and set our training parameters for our optimization. And then this is us actually training. I only train it for 2 epochs. It doesn't really take that long to do the 2 epochs, but you'll see it run. What you're looking here at loss and accuracy. The accuracy is how well it guessed, right? In terms of like the percentages that it gets right. For positive or negative. The loss is how good it's getting at guessing, right? So ideally you want low loss, high accuracy, right? If you start to see as you're training in your model, if you start to see that your loss is going up, even if your accuracy is going up, your model is not getting to those guesses, right, as good as what it should be, right? It's getting worse at guessing. So that's a good indication that over time, right, in static data, your model might perform well, but as you introduce new data or live data to it, over time your model is going to degrade significantly, right? So that's just an indicator for model performance as you're going through.
What is an epoch?
The epoch is just for your training steps. You have like the ability to set one pass. So for each epoch, it's going to iterate through the entire training sequence. The more number of epochs, the more number of training instances it's going to run. So if I set it at 2, right, it's going to do one pass. And then here it's auto assigning the steps based on the size of the data, the dimensionality of the data. I can manually set the steps in that epoch, which will allow me to essentially create bins that I want it to consider, as opposed to traversing the entirety of the data as it continues to train.
What's 782?
That's the number of steps. And then so you can see like 94 milliseconds per step. So that's the amount of training it takes at each one of those steps in that 780.
Yes, I see this one, the loss, well, the accuracy started out.
Yeah, and then, sorry, now that this is finished, so the loss and the accuracy is for the training. The validation data, which is the testing data that we passed in, also gets a val loss and a val accuracy. So once it's training, once it's done training, it tries to make predictions on the validation data, and it compares the true values in the testing labels with its predicted values to see how well it did. So when you're comparing these accuracies, your training accuracy could be higher than your validation accuracy, in which case you might have problems with like overfitting, right? Typically they're not going to be, you're not going to see like bad accuracy and then super high like validation accuracy. What you'll see a lot of is, really high training accuracy and then really low validation accuracy, and that's when it's going to be an example of overfitting. If they're slightly off, that's okay. You shouldn't expect those numbers to be the same. You just don't want it to be drastically different, right? So if we got 81% on accuracy, we would be looking, 75 to 80%, hopefully, on our validation. If we're down below 60%, then we're overfit, we're not performing. All right. I'm sorry?
Never mind.
Okay. So now that we've trained for our 2 epochs, remember this is only 2 epochs, this is not an actual, this is not how you would do this in real life, but we've only trained it for 2 because we wanted to be able to do something. You can see our accuracies are like 90% after 2 epochs. This data set was designed for training for education purposes. It lends itself very well to high accuracy with little amount of work, right? That's why I mentioned getting creative with other data sources, like pulling the reviews off of Google Play Store, Apple Store, that kind of stuff, because you can get a little bit more real world representation of how well it does. Okay. So now that we have our model, this part here, in most cases when people train a model, they'll just do like a model.predict. With most textual models, you can't do model.predict. You can do it with like image models. It's pretty easy to set up, especially with TensorFlow 2. With PyTorch, it's really easy to do like a .predict. However, you're constantly going to have to refer back to this point to be able to run that .predict, right? You have to come back here, input your new data, run the .predict. So what I like to tell people is it's better that once you've trained a model and you're happy with the training of your model, to export your model, right? And then you can save that model, which saves the weights. So I think, did you talk about the weights? Right, so all the things that it's learned, all the weights that it has, you can actually take all that, capture it, save it off, and then you can load it up into a new file, right? And then you can import it. And it imports that trained model and is ready to work on new data, right? This isn't showing you how to save off all the weights and stuff, but this does show you how to export the model so that you can then save it off. If you have questions about that, I'd be happy to help you. So what we're doing is we're essentially just creating another shell for our sequential model where we're using our model as one of the layers. And then we're setting the activation to sigmoid, right? Sigmoid is that logistic classification type output. So that activation says it's going to give me a binary response, So it's going to do that. I'm going to still compile it the same way I did. And then this is just to demonstrate real quickly us taking 2 completely new samples. So this is me. I just typed out like a few samples here. Obviously, they're meant to be very polar. One's supposed to be positive, one's supposed to be negative. We're going to see how well our model does. So I'm going to run those new samples. And then, as I said, just as a reminder, if you do any textual preprocessing, it's always good to redo that textual preprocessing on new data samples that are coming in. So I run that. And then I'm just going to make the prediction on those. So I should get 2 responses back. So the first one I get back is 72. The second one I get back is 51. If you look at the example sentences, the show was great. I enjoyed the special effects. That 72, right, is more positive. Right, so my model is giving me an assessment of the positivity in that sentiment. And so when you're looking at how to transfer this into a label, right, creating positive or negative labels, right, you can set your own thresholds, right? You can say anything less than 50 is going to be negative. You can see here that after training for 2 epochs, one of the things that we're not great at is getting the negative sentiment, right? Because even though I said it was terrible, there was horrible acting and special effects, right? I used key words that I thought would for sure give me a negative response. It still gave me above a 50, right? And as I trained more and, obviously put more effort into it, that would improve, right? But you could now take this exported model and you could take the text samples from that Twitter ad campaign, right? And it's just how we have a list here of new samples. you can go through and you can do the exact same thing we did with the IMDb data set. You can extract out those tweet samples, put them into a list, do your textual preprocessing and all that kind of stuff that we showed you how to do. And now you can assign a sentiment to those values. So that is kind of like the grand finale, at least from showing you the use case of it. I did leave it open-ended for you if you wanted to in your own time. You can take this notebook, and you can use this as practice. So you can try to apply it to that data set. You can, put more time in the textual preprocessing, look up different techniques. People mentioned stemming, right? You can see how that affects the performance of your model. You can also try out different layers, right? The model architecture I showed you is essentially for each sequential, for each model. Sequential model is just a collection of layers, right? So you go layer by layer, right? You can add in, a one-dimensional pooling layer, right? You can add a convolutional layer to it. You can do different things to see if it improves the performance of your model. Right? Very easy to work with. So hopefully this at least gives you a shell, something that you can practice in your own time. But that is it for the demonstration. I hope you all enjoyed it. Hope you learned something. If I have any final questions, everybody's tired, ready to go home. All right. Well, thank you all. Oh, yes, sir.
What can we do to have access to your model?
I'm sorry?
What can we do to have access to your model?
Well, we can talk price points. But thank you all. You've been great. I've enjoyed it. Jason?
Yeah, thank you.
Thank you.
Yes, sir. Thank you, Chandler. So as he said, the GitHub repo is on the meetup page. If you have any questions, I'm sure you're more than willing to be reached at. I don't know.
Yeah, my LinkedIn was on the meetup page. Absolutely, you can reach out, you can connect. I like to say I'm good about responding to people, so if you send me a message.
You're good.
Absolutely.
I know you're good.
Yeah.
So welcome to Tasting Food. If you guys want a sandwich to go or anything, and hopefully see you at the next event.